Hi everyone, welcome back to Coding with Bharat channel. So last week we had this lead code weekly 383 contest. Let me check the number to check if I'm right. Yeah, 383 contest, and we had four problems. It was kind of like a dud contest, like not too inspiring of problems, I would say, apart from the third problem. So in this particular video, I'm going to cover all the four problems, although the video title says just about the third problem. Uh, I'll start with the third, which was the most interesting one, and then probably cover the remaining in just a bit, right? Regarding the Z algorithm, which is a specific algorithm which was used for second and fourth problem, I'd probably make a separate video covering that in greater depth, right? So let's get started with the third problem and move on to the first, and then maybe talk a little bit more about the second problem. Okay, so let's look at the third problem first. It said that let's say we are given an m cross n image, right? What is this image? Essentially a matrix, you can say, of size m into n. Now what it wanted you to do was to look at a region of 3 into 3. So look at any region of 3 into 3 subgrid. Now in that region, we wanted the intensity between two adjacent cells. As you can read here, intensity between two adjacent cells should be less than equal to the threshold. Or you can say any two cells that are adjacent, either left to right or top to bottom, the difference in its values, the absolute difference in its values should be within a given threshold. So we are given a matrix and a threshold. We need to look at every 3 into 3 submatrix of this matrix, and I am interested in only those submatrices where any two adjacent elements have a difference, absolute difference of within the given threshold. Okay. So what you need to do is you need to calculate the average intensity of such a region. So this 3 cross 3, you calculate the average intensity. And now, if a particular cell belongs to multiple such regions, so as an example, let's say this 9 in the first image, like 5, 6, 9, right? So this 9 was belonging to two of such regions whose average intensities were x1 and y1. Then I need to put instead of this 9 x1 plus y1 by 2. So basically you have to take average of the average intensities of all the regions where this particular element is part of, right? That is what the question essentially talked about. So if I take an example, here it says we have these two regions. So threshold is 3. So 3 is the threshold. So if we look at the first submatrix also, which is in blue in the first image, then we can see that every adjacent 5 and 8, 5 and 6, 8 and 11, 8 and 9, all of them, any two adjacent left to right or bottom to top, if you take, they actually will have the difference, the absolute difference within the given threshold. So we had to take the average of this, which comes about to be, right, the average intensity, it says, of the first region is 9. So if you try to take the average, you'll see that it is 9. Then we also looked at the second region. So for the second region, it says the average is 9.67, and it says we need to round it down. So again, rounding it down, it goes to 9. So for first and last rows, the answer is simply 9. For second and third rows, since they are part of two regions, it was average of the two nines. So that is again going to be 9. So the result is in fact a matrix with all nines. Had the second region had an average of, let's say, 8 or 7, then we would have taken 7 plus 9 by 2, which is 8. If it was 8, 8 plus 9 by 2, which is 8.5. So rounding again down to 8. So for every such region, find the average, round it down to the integer, then find the averages of all those averages. Okay, that is what the question essentially talked about. If we look at the constraints, N and M was small, so not like 1000 into 1000. So there was scope of doing a lot more manipulation instead of just running n square, right? So that prompted me to think that this is more of an implementation problem and I should just wing it and code it in whatever way I want, right? So even if you look at my submissions, let me go to my submissions. You'll see that I did code out a random winging it out solution, and it led to a time limit exceeded problem. So if I try to see to this submission, during the contest, I made two submissions of it. So you'll see that this is a very, you can say, not a thoughtful solution, but a random winging it out kind of way of solution. Okay. So once I saw that, okay, I'm getting TLE, let me also look at the solution. So you can see that I have pretty much written randomly whatever I wanted, introducing new data structures like map, etc., wherever I wanted, right? Without thinking too much, like I was just coding it out. But then I realized, okay, this is not going to work. I need to structurally think what I want to do in this problem, right? And that is when I came up with the best solution, which actually got accepted. So let me talk more about it going into the whiteboard. So essentially what the problem says, let's say we are given a matrix. What we want to do is we want to look at every 3 cross 3 matrices, right? So in total, if it's an n cross m matrix, I would say that there are n minus 2 into m minus 2 matrices, right? So basically it's only possible to start a new matrix at n minus 2, one of the n minus 2 rows and one of the m minus 2 columns. So that is why this number comes into the picture. You cannot start a new matrix at, let's say, this point. So that is why these last two columns and last two rows, you cannot start a new matrix. You are just left with the upper sub matrix, right? That is why this number comes into the picture, that okay, we want to look at all the n minus 2 into m minus 2 possible starting points of my matrix, right? So let's say I start with this starting point. So now I clearly know that next two rows and next two columns, this would become my submatrix, right? So fixing the starting point automatically defines what 3 cross 3 submatrix I am looking at, right? Just plus 2 in terms of row, plus 2 in terms of column, and that defines the boundary, right? So I can actually loop at the starting points between n minus 2 and m minus 2, and that should be enough, right? Okay. Now for each such submatrix, you had to check first that every adjacent element follows threshold. That if you look at any two adjacent elements, it should follow threshold. Okay. Again, this was a part that I implemented very badly in the initial submission. But if you think about it, it's very simple. We need to look at every row and check the two parts of that row, they follow the condition of threshold with the previous one. Similarly, look at every column and again check that. So if in every column also everyone is just like within the threshold of the previous element, then we are done. So this checking if a region is a valid region or not actually broke down into two things: check every row and check every column. Okay, now that I have checked that entire submatrix, I can calculate the average. That was the next step. I need to calculate the average and put it as one of the values, one of the average values for these all elements of the grid. At last, what I can do is I can go to every element and look at their corresponding averages and do an average of it. So that is how I went about structuring my solution step by step, right? So let's see that in code as well quickly. Okay. So let me talk about this result a little later. Let's talk about the first step first. So what I did, I went about my starting point, finding the starting point. So I comma j represented my starting point. So starting point can start from anywhere to 0 till n, and j also from 0 to m. So n into m. I check this, that if plus 3, if doing plus 3 takes you out of the grid, right, then this is not a valid submatrix, right? This is not where I can start my submatrix as, right? Alternatively, you can run a loop up to image.size minus 2 and image0.size minus 2. That will also perfectly well work well, right? So these three steps basically to look at the starting point. Now that I have started starting point, I need to first check if this block is a valid region or not. So I have made a function check block that check if the submatrix starting at I comma j values the threshold, right, and return me a boolean variable true or false. So I actually wrote this function first and then went about completing the remaining parts, right? So check the block. If the block returns true, that means we have found a valid region. So if this val was true, then I went ahead and found the average of the matrix starting at I comma j. So I comma j matrix starting, you find the average of that block. Now, once I had the average of the block, I knew that this has to be included in the answer of the entire block. So I iterated on all the elements of the block, and in the result vector corresponding to that cell, I pushed this value. So now came the result in picture. What is this result? This result is a 2D matrix, and with every matrix I have a list of the corresponding averages that I'm storing in this result. So actually if you look at it, it's 3D vector. First two dimensions are I comma j, the element of the matrix. Third dimension is the list of corresponding values. So now what I did, I iterated on the I comma j, like again through every element of the matrix, looked at its result of I comma j. So result of I comma j represents what are the averages in this I comma j vector. Now, if that result size was 0, that means none of the regions where this element is a part of is a valid region. So I have to take the value as it is. So I said I just need to continue. Otherwise, I replaced my image with average of this vector, right? So this is how I structured my base solution, leveraging anything which was auxiliary. Like what was auxiliary? Calculating if the block is valid or not, finding the average of the result. So anything that was auxiliary, which could be done in a separate function, I had moved out so that I had less code to look at as of now. So this made the solution a lot more cleaner. That okay, you go through every starting point, you check that block. If that is true, you find the average, put it in a vector, and finally take the averages of all the vector corresponding to a particular cell. Okay. Now let's look at the auxiliary functions. So first is vector average, which took average of a vector. Nothing fancy here. Just initialize answer to 0, iterate on the vector, add, and return answer by v dot size. Remember, we needed to round it down to the smaller integer. So answer by v dot size. Similarly, let's look at the find average. This was, we had the entire matrix and I comma j, which is the starting point, and I want to take the average of the block. So run two loops for my row and column, added that into the value, and took value by 9 because I have 9 elements corresponding to that submatrix, right? So this is done. Check block, as I said, to check if the block follows threshold parameter. It used to check all the rows and check all the columns. So let's look at check rows and check columns. So check row, go through every row, right, and check if each element is following the threshold with the previous element. So go through all the rows, right, from 0th row to second row, calculate the row number, actual row number. So I plus this row, so I plus 0 will be the first row, I plus 1 will be the second row, I plus 2 will be the third row. Go through all the columns, first to third columns, and look at the average. If that average is more than threshold, already return false, otherwise return true. And same way I wrote check column. Go through every column, go through the row for that column, and check if the average is within the threshold or not. So actually segmenting it into parts made this look like a cakewalk. So you'll see that I might have coded this in just about 5 to 7 minutes without any errors in the first go. So sometimes, like not always I'm saying this is a good advice, but sometimes when you feel that the implementation could be complex, it is good to take a step back and then note down that okay, how do I high level way do what is mentioned in the implementation, and then throw away the secondary things to the function. Then think about those functions. How do those functions act and how will they give me the relevant values to the, in a way, coordinator function. So this was essentially my coordinator function, which was actually responsible for calculating the result, but throwing away the extra tasks to the corresponding functions. This is actually a very important principle in clean coding as well. So those of you who are familiar with it might relate to this much more. Cool. I think this was the only interesting problem I would say in the entire problem set. So let me go over the remaining problems also quickly, just to cover it up in one video. So the next problem was this ant on the boundary, the first problem. So what it said, that let's say there is an ant which is at a boundary. Uh, we have an array. We look at every element of the array and make that much jump. So for example, if you look at the first example array, we start with 2. So this ant will make a 2 jump forward. Then there is 3. So 3 more jump forward. Then minus 5, 5 steps backward. So we need to know how many times the ant moves back to the starting point. So simple, just keep on taking sum. As soon as you reach 0, that is a point where ant is back at the initial position. So you need to just count number of 0 with which you get in calculating the prefix sum. Let's look at this example also. 3 step forward, 2 step forwards, 5, minus 3. So you go to 2. Then minus 4, you go to minus 2. So directly you move back. You don't land at 0. So the answer is 0. Like there is no position where you go back to the initial point. So yeah, the code for this was relatively simple. I'll just go to the submissions to quickly go over it. Okay, so simple idea. You initialize count to 0, sum to 0, iterate on the elements, add it to the sum. Whenever you get sum as 0, so you keep on calculating running sum. Whenever your sum is 0, that means you need to increment the count and return the count at the end. So yeah, this was the simple code for it. Okay, so if you have any doubts in this, I've moved through this very quickly. If you have doubt in this or the previous question, you can go ahead and put it in the comments. Let's move to the last problem. Uh, as I said, this problem was more around knowing a particular algorithm. So I'll talk a little bit more about it, but I'll cover that algorithm in greater depth in one of the separate videos because it's a complex algorithm to understand, right? Okay. So this problem said, let's say we are given a string, and apart from that string, we are given an integer k. What we do every time is take the first k characters of the string, remove them from the string, and add any k characters at the end of the string. So for example, we can remove ABA initially and put, let's say, BCD at the end or XYZ at the end, whatever we want, right? So take k characters out, replace it with some new characters, whatever you want, and put it at the end, right? And you keep on doing it. So you want to tell after the first step, when is the next time that you can try to bring about the same string back. So as an example, in this particular scenario, first we take this ABA out and we put instead of this BAC at the end. So we get CABA BAC. Then we'd again take this CAB out, right? So this is what we get next, CABA BAC. So again we take this CAB out and actually put ABA at the end. So we get back this string. So after how many steps you can get back the same string, right? That is what we need to know. Okay, so let me go ahead and explain this a little bit on the whiteboard. Okay. So first of all, let's say we have a random string like this, and let's say k is 5. So at one point, what you would do, you would take 5 characters out, replace them with anything that you want, and put it at the end. Next step, you'll again take 5 characters out, which would include one of the replaced characters. But let's just think about it. If we already know the string, the k, we can ensure that whatever we are putting now at the back, so we are taking out abcd, we want abcd at the front, then whatever we are putting at the back, I would put it in such a way that the replaced characters always are the ones which let me construct the string quickly. So I know this a is wasteful because with 5 k equal to 5, I'll be taking up the first character, so that is wasteful. But what I can ensure is next 4 characters that I'm putting should be same as the first 4 characters of the string, because then I would not need to do another step. Same thing, when I take this 5 out and put something on the back, I'll again put E, F, G, H, I to make sure that they match with the same string. So the characters that you are putting back, you have full control on it. You can literally put anything. So once all the characters of the given string are expired, you would for sure get your result, right? So at max, I would say you would need to do n by k plus 1 steps. For example, here also we had 9, right? So 9 by 5, which is 1, plus 1, which is 2. So at max 2 steps, right? Why? How this n by k plus 1 came? Because assuming that n is not completely divisible by k, then after n by k steps, a few extra characters would be left, which also would need to be replaced. So one more step. If it's perfectly divisible, if there were 10, then actually you would do in 10 by 5, which is 2. So if perfectly divisible, then n by k, otherwise n by k plus 1. So with this idea in mind, this is the maximum answer that we can look at. We can improve it if what happens, after doing some of the steps, I get back same string as the beginning. So let me look at it again. So let's say I have A, B, C, D, right? Then again A, B, C, D, then again A, B, C, D. Okay, let's say I have this. So now, if I think about it, and K is let's say 4, or let's take 2. So if I think about it, when I replace the first 2 characters, nothing can be done. When I replace the next 2 characters, after that, the remaining are in same order as the original string. So if I had replaced this AB with AB and this CD also with this CD, my job would actually be done after just 2 steps and not taking 4 plus 4 plus 4, which is 12 by 2, 6 steps, right? So the answer would be 2 in this case. How did this come about to be? Because the remaining character after certain removal match exactly with the prefix, with the starting of the string. If that happens, then I can make sure that the new characters that I put, they match the remaining suffix and not the beginning of the string. Let me take another example. Let's say this one in fact was E, and we had the same k equal to 2. Now, when I take this AB out and this CD out, I'm not done. Why? Because this is ABCE, but I wanted ABCD in the beginning. But now, when I take it 2 more times out, like ABCD, ABCE, then this remaining ABCD matches with the prefix. So whenever I am at an index that the remaining string where matches with the prefix beginning characters of the string, then I can say my job is done if I reach that point. Because now I can make sure that the remaining elements that I have removed so far, they match the remaining part of the suffix. So that is an important point to note here in this particular problem, where we stop at that point, we stop at that index where remaining part of the string from index till the end, that is exactly same as a prefix of my given string. So this remaining part is same as the prefix of the given string. And now to do this quickly, to check if at any given index my remaining string is same as the prefix, we had a proper Z algorithm in place which gave us a Zi. So Z of I, if I look at it, gives us the number of characters after this index which matches the starting of the string. That is exactly what Z algorithm gives us. So Z of I is how many characters after I in this string matches the 0 to, like 0 to some particular point. So for example, if Z of I is 3, that means I plus 1, I plus 2, these three matches 0, 1 and 2, the starting three of the string. Cool. So based on this Z algorithm, I implemented my solution. Let's look at that. Right. So this is exactly copy paste of Z function from one of the open source pages, right? So I have had my Z function. I have my Z of I available with me. What I did, I started with I equal to K. First time we remove the first K characters. So I'm at index K. And I'll move by plus K because every time we are removing K characters. So I equal to K, I less than word dot size, I plus equal to K. Count equal to 1 because one step we have to do. We have to remove the first K characters that is given in the question. Like you cannot be at the beginning. Okay. So if the I that am I at, if that Z of I is same as the remaining characters, so n minus I, so word dot size minus I, if it's same, that means the remaining characters match with the prefix. Then what I can do is I can simply return the number of steps that I've taken so far. So for example, if after removing the first K characters only, like we have ABCD, ABCD and K is 4. So when I look at, let me go back to my screen and show that. So let's say we had ABCD, ABCD. So if I look at Z of this place, it would be 4. So when I remove the first 4 characters, let's say K equal to 4, so I am here. Now we look at Z of I, it is same as total minus I. So 8 minus 0, 1, 2, 3, 4. So 4. So since Z of I is same as the remaining characters, I can stop here. So my count will remain as 1. Had it been this, then here Z of I would be 3 characters match ABC. So it is not same. I'll move on. But here Z of I would match 4. So I'll stop here after doing 2 steps. So that is how Z algorithm could be used in this particular question. You move KK steps at any point. If you see the remaining characters exactly match with the beginning, then you can break here and return whatever number of steps you have taken in the past. Okay, so this is what I've done. And otherwise, if I don't return, then I'll do count plus plus because I have to remove the next part also now and move on to the later part. In worst case, I will keep on making jumps of k and finally exit the string. So once I exit the strings, the number of steps that I have taken, that are just enough because now I can introduce new characters in whatever way I want. So I return count plus plus. So that was the whole idea of this question. The main piece of this was this z function, which is on in nature. So yeah, otherwise in brute force you would actually go character by character and compare, which is going to be n square. So to avoid that, we have this onz function in place. I'll talk more about this in a separate video where I cover Z function in detail because it's a complex algorithm like KMP or Rabin-Karp, if you know that. By the way, even with KMP and Rabin-Karp, it was possible to solve this question, but it was more complex. Like Z was almost direct here. Okay, cool then. If you like the explanation so far, do give this video an upvote and subscribe to the channel, right, if you're new here. So let's see you guys in the next one where I'll probably discuss Z function in detail, and one more video that I've promised for this week, which is on prefix sum. That also would come shortly. Okay, bye bye.